The Sun, the centerpiece of the solar system, once thought to be a god and now worshipped as one of the most important celestial objects in the entire universe. But what is it made of? Where did it come from? Herein lie the answers, my friend. But remember that above all else, the Sun is just a giant ball of hot gas. Hi, I'm Alex from Space Vikings, here to take you on a little tour of the Sun. So I hope you remember to pack your sunglasses. Approximately 4.6 billion years ago, large clouds of hydrogen and helium were gravitationally attracted to one another until from one very dense point they burst life into what would become the solar system, leaving the Sun at the center. The Sun is 864,000 miles wide. That's 109 times larger than Earth, and it's 333,000 times heavier. It's so large that you'd be able to fit 1.3 million Earths inside of it. That's pretty big, but even our Sun is dwarfed by some of the giants that we've found in the universe. The largest star that we've ever discovered, one called UY Scuti, is so large that we could fit up to 4 billion of our Sun inside of it. The composition of the Sun is actually very interesting, and if you were to cut the Sun in half, it would look a little bit like this. The outer atmosphere of the Sun is called the corona, and temperatures there vary between 1 million and 2 million degrees. And the next layer down is known as the chromosphere, and it's a lot colder than the corona, with temperatures varying between 4,000 degrees and 35,000. Below that you have the very thin photosphere, which reaches temperatures of 6,000 degrees. Underneath that you have an area which is very similar to something we have on Earth, known as the convective zone, and temperatures there can reach 6,000 degrees as well. Underneath that you've got what I'm calling the danger zone, but is actually called the radiative zone, and temperatures there can hit 7 million degrees. And finally in the very centre you have the Sun's core, where temperatures can reach up to 15 million degrees, which is just a little bit colder than the shower when you first turn it on in the morning. Right now the Sun is displaying nuclear fusion, where it crashes two hydrogen atoms together to create a helium atom and lots of excess energy. However, in approximately 5 billion years, the Sun's going to run out of hydrogen to play with, leaving it with just the helium to collide with each other. The result of this process will mean that heavier but colder atoms will start to appear within the Sun. Overall, this just means that the Sun is going to get a lot colder, but much, much bigger. As the Sun expands, its outer layers will engulf Mercury and Venus. Scientists are yet unsure as to whether it will engulf the Earth or whether Earth will just orbit in a very dangerously close position. Either way, we're long gone. This doesn't necessarily mean the end of life itself within the solar system though. You see, as the Sun expands, the habitable zone around it will move as well. The habitable zone is the region where liquid water can exist, considered by most to be the area ripe for life to evolve. So who knows? As much as we might not be living on Earth in 5 billion years, we might have moved to one of Jupiter's moons. At approximately 11.2 billion years old, the Sun will have reached a size 100 times that of what it currently is. Approximately 1 billion years after that, the Sun will expel its outer layers that engulf Mercury and Venus into an area of space known as the Helium Flash. This process is what's known as the nova, and as a result, the Sun will go from being huge to being very small indeed. At this time, the Sun will only be a little bit larger than Earth, but it will be much, much smaller than giants like Jupiter. And eventually the white dwarf Sun will use up the rest of its energy and become a black dwarf. Whilst we believe this to be the case, there's a chance that white dwarfs could stay in that state for up to 50 billion years. After all, the universe is only 14 billion years old, so we haven't been around long enough to see this happen. But let's not panic over the death of the Sun. We and the Sun sit about here within the Milky Way galaxy. And when you zoom into that, the Sun is very, very small in comparison to the rest of the galaxy. Yet it has such a massive gravitational control around it. But what is actually within that? We've already toured the planets and the asteroid belt, but next week we'll be going over what lies beyond Neptune, in an area known as trans-Neptunian space.